Okay, this time we have a definite integral. Here we have the integral from 1 to 4 of the square root of 8x plus 3 dx. We begin pretty much the same way as before. We begin by allowing u to be equal to the inside part of that composite function. And that would call for us to have a du of 8 to go with our dx. So now I'm just going to do a little bit of rewriting here. Rewriting that square root as an exponent. And I need to have an 8 to go with the dx. I just have a dx right now. So I can put an 8 there as long as I divide by it later on. Okay. Now at this point there's really two options for how to proceed with this definite integral. One is, as you make the change of variables, is to recognize that this is now an integral involving u. So the 1 to 4 was talking about x. So you just got to recognize that they're in terms of u's and just don't bother with what they are right now. And then you can carry it through much like you would for any other integral by substitution. So we go through. The antiderivative of u to the 1/2 is going to be u to the 3/2. Divided by 3/2. Dividing by 3/2 is the same as multiplying by 2/3. So simplifying, we will have 1/12 u to the 3/2. But u to the 3/2 is the same as 8x plus 3 to the 3/2. And now we can evaluate that from 1 and 4. Now I'm going to ask you to go ahead and take a moment and try to work that out yourself. Evaluate that from 1 to 4 and get an answer. And then catch up with me. Okay, so when I do that, I get way too much stuff. Hold on for just a second. Hit the wrong button. Sorry about that. I get 35 to the 3/2 minus 11 to the 3/2. And when I work that out on a calculator, that is approximately 14.21. Okay, so that's one way to do the problem, is to don't bother changing the u's and then eventually, change back to x and then work out with those old limits. Another way to do it is to go in and say, hey, since x is going from 1 to 4, then I can figure out what u is going from. So u, well, when x is 1, u would be, work it out, 11. And when x is 4, u would be 35. So I can pencil those limits in. So you say, well, what's the difference? Well, now when I carry this through, I have the integral of u to the 3/2 going from 11 to 35. And see, because the limits are now in terms of u, I don't have to change them back to x. I can just evaluate u at 11 and at 35. And you see we get the same result that we had before, which of course will work out to be at 14.21. So you can do it either way. It's just a matter of whether you want to bother changing them. If you change them, don't bother changing them back. Or just leave it all in terms of x and work it out in the end. Okay, so that's how we handle a definite integral.